Okay, section 2.5 will be exploring inverse functions. Our essential question is, how do inverse functions apply to real-life situations? This is almost more of an activity or a lab assignment than it is a set of notes. I'm going to kind of talk you through it and explain how you can get started with it, and then I'm going to have you complete it on your own. And after you've done that, then I'll supply the answer so that we can have more discussion about it. So in this section, we've got this word problem. So let's see what it says. Chandler and Isaac both like to ride bikes for exercise. They were discussing whether or not they have a similar pace so that they could plan a time to bike together. Chandler said she bikes about 12 miles per hour, or 12 miles in 60 minutes. Isaac looked confused and said he does not know how many miles he bikes in an hour because he calculates his pace differently. So, 1. Using Chandler's information, determine the independent x and dependent y variables. Okay, so independent, of course, is going to be the one that guides the dependent variable. The dependent variable is going to be based on what the independent variable does. So here, Chandler said she bikes 12 miles per hour, or 12 miles in 60 minutes. So you've got time and you've got distance. And measuring it in terms of miles per hour, the time is going to dictate the distance. All right, so if the time is the one that's determining how far Chandler bikes, time would be independent variable. So time is independent. Let's say x equals time, which is independent. And then the y value is going to be the distance, which is the dependent variable. Okay, so whatever amount of time passes using this calculation, that amount of time determines the distance that Chandler bikes. So 2, since Chandler uses time to determine the distance she travels, determine how far she will go in 1 minute, 5 minutes, 10 minutes, etc. So I'm going to let you do this, but I'm just going to kind of get you started with it. If she travels 12 miles in 60 minutes, so in 1 minute, you can calculate that if you just divide 12 miles, if you divide, she travels 12 miles in 60 minutes. So if you divide 12 by 60, so you can think of it as a ratio. She's got 12 miles in 60 minutes. If you want to know how far she travels in 1 minute, then you would divide 12 by 60. And 12 divided by 60 will give us 0.2. Okay, so now that you've got this information, time of course is in minutes. Now that you know that if she travels 0.2 of a mile in 1 minute, you can fill out the rest of the table with that information. So you can fill out how long it takes, 5 minutes, 10 minutes, etc. Once you've done that, you can complete number 3, write the equation for Chandler's pace using time in minutes as the independent variable and distance in miles as the dependent variable. Once you've done that, you'll sketch a graph with a domain from 0 to 120. And to help you out with this, for your units, let's see, you would of course make sure that you label it. So if we said x is time, and we said y is distance, and it will probably work well if you can number your x-axis counting by 5s. And I'll let you finish that out. And then over here, you could count by 2s. Counting by 2 should work well over here. Put it there. So if you continue that, you should be able to complete this part. Once you've completed the front page, I want you, and you can work with a neighbor, that's fine, but I want you to do the same information for Isaac. So they'll give you the information that you need for Isaac. You're going to follow the directions, and then you're going to be asked to answer some questions comparing the two. So definitely let me know if you have questions about how to do this, but I want you to take some time to think about it before we discuss it together. All right, thank you.